The Van Dyck et al. Article on Blackboard provides a nice example for how to illustrate your results in an organized form for consumption by readers. So when you're submitting to a journal, how do you want to display the results of your hierarchical analysis? And so I wanted to give you an illustration of how this has been done in one of the top journals, and so that you could emulate this example and plug in your own data when you are writing up your own results. Okay, so before we go through what the authors did here, I must interject very quickly that there is no set way that I know of to make a table to display your results. I have seen tables in the same journal and across journals, different studies. The authors may perform a similar analysis, but they'll display their results slightly differently. And I'm not sure why this is, but it's not something that we need to really be concerned with. Just know that it happens. You may have noticed this yourself. And I think that a good rule of thumb when you're thinking about writing up your results and how to make the table is to go to a top journal in your field for ideas, and then copy the format of their tables and then replace their numbers with your numbers, and then simply send it in. And if a reviewer has a question or wants you to add or subtract an element of your table, alter some things, then you can do that. But I find that going to a journal is a nice, and looking at how they displayed their results is a nice place to start. And so that's what I'm doing here for you, is I'm giving you an example so that you can have a place to start when putting together a table. And know that you can, again, that there's this practice varies greatly. The exact way that the tables are put together and the way they look can vary dramatically, and that's okay as long as it's readable and it contains all of the things that the readers need to know and that the reviewers are happy with, then it's okay. So table making is partly a science and partly an art, I would say. Okay, so for this study, the authors were looking at error management culture and org performance. And error management culture is simply fostering an environment in a workplace in which errors are freely discussed and communicated. They're planned for, and when they happen, they're dealt with quickly and efficiently. And so training people to behave this way has been very helpful, as the study showed, specifically impacting a couple of DVs. The first one was firm goal achievement, or did the organization meet its objectives? And second, return on assets in the year after the intervention was implemented. So the authors, again, had two DVs, and we can see them across the top of this table. You can see firm goal achievement and return on assets in 1998. Those are the two DVs that they were trying to predict. You can see that they used step 1 and step 2. So they refer to the blocks as steps in their table, as you can see on the far left column. And they had a few predictors, or I'm sorry, covariates that they were looking at. The size of the organization they thought would matter for org performance. They thought the industry sector might matter, and I'm not sure how they coded that. I'd have to go back and look, but we'll talk more about coding later anyway. And finally, return on assets in 1997. So here's another case of an example where we want to use as a covariate an indicator of the trajectory of the organization before the intervention was implemented. So this is like a baseline, and you're going to see this as a pattern coming up probably in various studies, and that is people use baseline, the baseline as a covariate in the analysis. So we're parsing out what was the organization like before the intervention happened. So we can imagine return on assets in 1998. That is probably predicted by return on assets in 1997, the previous year. So remember, a covariate is something that's correlated with our DV of interest, and we want to parse out that variance so that we can see the relationship more clearly between our predictor of interest and our outcome. So again, researchers probably didn't, in this investigation, they probably didn't care as much about the B weights of the covariates necessarily, but they just wanted to understand the incremental variance accounted for by their focal variable, which was error management culture. So they do report the B weights, however, for all of the predictors, and that is typical for tables when you submit for publication. The reviewers and the readers will want to see all of your beta weights, so you typically will report those. Note that this table did not report the B weights. That is something that, again, varies across different studies. Some report both, some report just the betas, as you can see here. I think that recently, this study was done in 2005, I think recently there's been a push to include B weights more. I think I mentioned that before last week. So the DF is 3 and 43. So typically when a DF is reported in this way, one number, comma, another number, that means that the DF, the first DF is the numerator DF, which is 3. It looks like we have 3 covariates in block 1, size, industry sector, and return on assets in 97. And then the next DF number is the denominator DF, which is n minus k minus 1. And that makes sense because in the note below the table, we can see that the n was 47. So if we have 47 minus 3 minus 1, that would be 43. So that makes sense. And I'm looking on the first column, by the way, under firm goal achievement, DV. So notice how they did this table. They were able to fit 2 DVs in this one table. That's not always possible, but they did it very well in this case. If they had 3 DVs, they might have to rethink how to do the table unless they could squeeze it all in. So I'm just thinking, giving you kind of an insight into how I'm thinking, because when I'm thinking about, okay, the different possibilities for a table, and your particular study is going to have different kinds of data, different numbers of DV. You may have just one DV, so and the different ways that you could lay out a table under those different circumstances. So that's my thinking there. Okay, so we have the change in R squared from block 1, or step 1, which is the covariates, and then we have the jump in R squared due to adding error management culture in the second block or step. And that is 0.30, which is a pretty good number. I mean, that's probably a lot. And so we have the change in F, which is not always reported in every table and every study either, but these authors chose to include it. And then we have the final R squared, which is 0.47. Notice that that is just the change in R squared added together. So we have 0.17 in block 1, 0.30 in block 2, and add them together, and that's 0.47. And so that's a really big effect size, actually. 47%, wow. For firm goal achievement, that's pretty cool. And of course, that's significant. So you can look for yourself. I'm not going to go through the return on assets in 98, but you can see that the pattern is the same, and we have a significant R squared incremental change from the addition of error management culture in the second block, and it's not quite as big as the first one, though. It's looks like it's 0.06, so it's a 6. It looks like a 6% increase rather than a 30% for firm goal achievement. So take a look at this table, understand all of the elements. I would say don't worry so much about the change in F, but the rest of it, know what it is, know what it represents, and look that through and just become very familiar so that these strange things don't seem so foreign. Like, for example, the change in R squared is often denoted as a delta R squared. That just means change in R squared, in case I haven't mentioned it before. So delta, that triangle, R squared just means the change in R squared. A delta F is the change in F, etc. So take the time to become familiar with these different symbols and different notations so that it doesn't seem as foreign or as scary. So that's the goal as we move through this.